This video will learn how to use angles of elevation and depression to solve problems using trig. So angles formed below a horizontal line are called angles of depression. So in this example, this angle right here would be considered an angle of depression. So if you thought about someone standing up here, they would be looking down. That would be depression. Angles formed above a horizontal line are considered angles of elevation, so that would be this angle here. And again, if you imagine someone standing here, they're looking up, so that's considered elevation. So this first few examples, we're just determining if the angle shown is elevation or depression. So if you look at angle 1, this bird is looking down, that would be depression. In the second one, the person is looking up at the bird, that's considered elevation. This third one, the person is looking down at the ground, so that would be depression. And then lastly, down here, this would be looking up, so that is elevation. The challenging part about these problems is going to be that you have to draw your own picture. So for the first one, I've told you this is elevation. At some point, you won't be told that, but it says find the shadow cast by a 10-foot lamppost when the angle of elevation of the sun is 58 degrees. Find the length of the shadow rounded to the nearest tenth of a foot. So essentially you have this lamp post. So here's my lamp post, and it's casting a shadow on the ground. So the sun is back here. The shadow cast by the 10-foot lamp post. So the lamp post is 10 feet. It says the angle of elevation, so that would be here, because imagine, you're looking up at the sun, 58 degrees, and we want to know how long the shadow is, so that would be x. Once you get your picture drawn correctly, the problems really aren't that bad because it's what we've been doing. So we're going to use trig to solve this. So if I start labeling, I have opposite, hypotenuse, and adjacent. There's nothing out here labeled with the hypotenuse, so I'm not concerned about that side. Remember your formulas. You can use the trick SOHCAHTOA to figure out which one you would need to use. In this example, I have opposite and adjacent, which would be tangent. So I start filling in my formula. Remember, theta represents the angle, so tan 58 equals the opposite side is 10, the adjacent side is x. Then I begin to solve, so I'm going to multiply by x on both sides. Those x's here cancel out. I'm left with x times tan 58 equals 10. To get x by itself, I would divide by tan 58, and those would cancel on both sides. And then I'm left with x equals 10 divided by tan 58. And then you just want to type that into the calculator of your choice. Just remember, whatever calculator you are using needs to be set in degrees. You get 6.248, and they tell us to round to the nearest tenth, so 6.2 feet. In our second example, a nursery plants a new tree, attaches a wire to it to support the tree while the roots take hold. An 8-foot wire is attached to the tree and to a stake in the ground. From the stake in the ground, the angle of elevation is 42 degrees. How high up is the wire tied to the tree? So again, you want to draw your picture. So you have a tree, you have a wire attached to it that's holding it to the ground. It says the wire is 8 feet. From the stake in the ground, the angle of elevation is 42, so here's that. And it wants to know how high up the wire is tied. So from here to here, it wants to know how tall is that. Once you get your picture drawn, again, we're just using trig to solve. So I start labeling. This would be opposite, and this would be hypotenuse. Thinking back to SOHCAHTOA, I have opposite and hypotenuse, so I would be looking at sine. So sine 42 equals opposite, which is x, hypotenuse, which is 8. This time to solve, I would just multiply by 8 on both sides, and I get x equals 8 times sine 42. So type that into your calculator, again, making sure that it is in degree mode, and you should get 5.35, which rounded to the nearest tenth would be 5.4. Another example says a ladder leans against a brick wall. The foot of the ladder is 6 feet from the wall. The ladder reaches a height of 15 feet. Find the angle that the ladder makes with the wall to the nearest degree. So if we start to draw a picture for this one, I have a brick wall. So here's my wall. We have this ladder that's leaning against it. And so here's where my triangle's formed. It says the foot of the ladder is 6 feet from the wall. So that's this section here, 6 feet from the wall. The ladder reaches a height of 15 feet on the wall. So right here, this is going to be 15. And then it says, find the angle the ladder makes with the wall. So that's this angle right here. So I actually crossed off the top because it used to say elevation, but I'm actually thinking this is depression. So I just needed to correct that. Sorry about that. And then we're going to solve. So even though now x is an angle, we're still doing the same thing. So we label. This is opposite. This is hypotenuse. And then this is adjacent. If I look, there's nothing out here on the hypotenuse, so I'm not going to use that. So I'm using opposite and adjacent. Thinking back, that would be tangent. So now I'm going to set this up. So I have tan, my angle, which is x, equals opposite, which is 6, over adjacent, which is 15. Remember, when you're trying to get tangent and x apart, the inverse is the tan with the little -1. So this ends up being tan -1, 6 over 15, which we find out is 21.8 degrees. In the next example, it says a lifeguard is sitting on a platform looking down at a swimmer in the water. The lifeguard's line of sight is 8 feet above the ground, and the angle of depression to the swimmer is 18 degrees. How far away is the swimmer from the lifeguard? So this time when I start drawing, I have a lifeguard up here on a platform looking down at a swimmer in the water. And if you think back to our very first example, the depression triangles were always upside down. So I always draw my depression triangles upside down. I just recommend that you do the same. The lifeguard's line of sight is 8 feet above the ground. So that would be here. The angle of depression to the swimmer is 18 degrees. That's here. How far away is the swimmer from the lifeguard? So that would be the hypotenuse. So when you set this up, again, we just label opposite, hypotenuse, and then adjacent. Opposite and hypotenuse are the two that I'm concerned about, which is sine. So sine 18, 8 over x. When we solve, we're going to multiply by x on both sides, which causes these x's to cancel. So we have x sine 18 equals 8. To get sine 18 away from x, we would divide both sides by sine 18. These sine 18s would cancel, and I'm left with x equals 8 divided by 18. Typing that into Desmos, again, make sure your calculator is in degrees. You would get 25.88, so 25.9 feet. Sine. For this next example, an airplane pilot sights a life raft at 26-degree angle of depression. Remember, anytime you have an angle of depression, you should be drawing an upside down triangle. So there's my plane. Here's my triangle. Here is the raft. The angle of depression was 26 feet. The airplane's altitude is 3 kilometers. So remember, altitude means height, so 3 would go here. And it says, what is the airplane's horizontal distance from the raft? Horizontal means from left to right, so that is here this time. So horizontal distance, they said use D. I labeled that there. So then again, we start labeling. This is opposite. This is hypotenuse. This is adjacent. I'm not concerned about the hypotenuse. OA, that goes with tangent. So tan 26 equals opposite over adjacent, which they said to use D. If you want to use X, that's totally okay. We would multiply by D on both sides, causing these D's to cancel out. I get D times tan 26 equals 3. Divide by tan on both sides. These tan 26's will cancel. The distance equals 3 divided by tan 26. So when I type that in, I get 6.15, which would round to 6.2 feet. Sorry, kilometers. So the next two are a little more challenging, and they involve an extra step before you begin solving or after you solve. So these are not going to be types that are on the assignment, but they are something that you should be familiar with. So this one says, suppose you stand 53 feet from a wind farm turbine. Your angle of elevation to the hub of the turbine is 56.5 degrees, and your eye level is 5.5 feet above the ground. So for now, I am going to exclude this information, and I'll show you what you do with it at the end. So starting my problem setup, I have the wind turbine. Again, guys, not an artist, just doing the best I can. And then you are standing some distance from the turbine, and you're looking up at it. So essentially, here is your triangle. You're 53 feet from it. The angle of elevation, so remember you're looking up, that's 56.5 degrees. And we're looking for the height of the turbine. So I'm going to start by solving this. So this side's the opposite, this side's the hypotenuse, this is adjacent. I don't really have anything labeled on the hypotenuse, so I'm using O and A, which is tangent. So tan 56.5 equals O over A. I'm solving for X, so I'm going to multiply by 53 on both sides, and those would cancel out here. So 53 tan 56.5 equals X. When you type this in, you get 80.1. And if you really think about what you just found this height right here. But it says, how tall is the turbine from the ground to its hub? So you really want the entire height. And the part we're missing right here is the height of this person's eye level, which in the original problem said is 5.5 feet above the ground. So here I have a height of 80.1. Here I have a height of 5.5. And if I add those together, I'm going to get the total height, which is 85.6 feet. For this last one, I have an airplane approaching a runway. The pilot begins a 3-degree descent. So right here, descent means depression. So we should be drawing an upside down triangle. Down here's your airport. And this problem has to do with sea level. So personally, when I draw it, I like to pretend that this airport is on a very sketchy cliff. Here's the sea. So it says the airplane starting from a height of 2,714 feet above sea level. So right here, here's the airplane, 2,714 feet above sea level. But the airport is 1,700 feet above sea level. So right here, 1,700 feet. So in terms of my triangle I've drawn, this height right here is not truly 2,714 feet, and it's also truly not 1,007. If I want to find that portion, I need to subtract those two numbers. So the height I care about is 1,707 feet. Going back to the beginning, it said that it's a 3-degree descent, so that's my angle of depression. And it says, to the nearest 1/10 of a mile, how far from the runway is the plane? Now, it doesn't say horizontal distance, it just says how far. So the closest path is this, my hypotenuse. So I'm going to label that x. Then I'm going to label, so opposite, hypotenuse. That means I'm using sine. So sine 3 equals opposite over hypotenuse. Multiply by x on both sides, x sine 3, these cancel, equals 1707, divide by sine 3, and you get 32,616.2 feet. Now, sometimes when we get really large answers, that freaks us out, but think about what you're finding. You're finding the distance of a plane from the runway. So it makes sense to get an answer that large. However, if we were talking about the height of a tree, then you might want to be concerned.